This video is going to cover the odd ones because there's already a video covering the even ones. We already did number 1 on a previous video. We're going to jump to number 3. So if you're taking a final exam, ladies and gentlemen, and you have this equation and they ask you to solve it, I would try to factor, split, and solve. But if you can't factor, you could always fall back on the quadratic formula, which is what we're practicing on this top half of the worksheet. Even if it's factorable, I want you to practice the quadratic formula. So again, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. Say it in Spanish. No, I'm not going to say it in Spanish right now. Anyway, the way to use this formula is to replace the letters with parentheses. So that's what you need to do. You need to replace the letters with parentheses. Identify your A, your B, and your C, and then plug in your A, B, and C. So your B value is right here, which is negative 4. Right here, negative 4, that's your B value also. Your A value of 1 is down here and up here, and the C value of 6 is at the very end. So you always start with your discriminant value. So negative 4 times negative 4, because that's negative 4 squared. Negative 4 times negative 4 is positive 16. Let me just write that number right here on the side. And then 4 times 1 times 6. 4 times 1 is 4, times 6 is 24, and there's a minus sign between it. So I really have a 16 minus a 24 on the inside of the square root. So let me rewrite everything. I have a positive 4 out here because the minus minus changes to plus plus. It's over with the plus or minus and the square root. And inside the square root, I might as well do the 16 take away 24. What's 16 take away 24? Negative 8, and 2 times 1 on the bottom is 2. Now, you should try to simplify this radical and continue working, but we know it's a negative, and if it's negative, you can't do the square root of a negative. That's going to be imaginary. So they're asking for the answers. There is no solution on this one. So you could write out no solution, or you could do this symbol like a 0 with a line through it. You cannot get real answers. Now, what does that mean visually? If you were to graph this quadratic trinomial equation, which is a parabola that opens up because the a value is positive, you could find the vertex if you wanted to by doing negative b over 2 times a, and then plugging that value into the x's to find the y value. And you could use the pattern 1, 1, 2, 4, 3, 9, or you could use the input-output table to actually graph it. But what I'm trying to get at here is if we actually did all that, we would see that this parabola that opens up will not cross the x-axis. Remember, the solutions are your x-intercepts. So just to give you an idea, if you were to try to graph this, your parabola would not cross the x-axis. That's why there's no solution. Let's move on to number 5. Once again, let's use our formula. We're always going to be using the formula on this top half of the worksheet. And let's practice using the parentheses. Negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. Of course, the a value is 2, the b value is 9, the c value is negative 5. So the b value is 9, put the 9 right there and right here. A value is 2, put it down here and up here. And the c value is negative 5, put it right here in the parentheses at the very end. And once again, you start with the discriminant value. That discriminant value is the math that is inside the square root. And if I go 9 squared, I'll get 81. Let me just jot that down right here on the side. And if I do negative 4 times 2, that's negative 8, times negative 5. Negative 8 times negative 5 is positive 40. So I really have 81 plus 40 inside of the root. So let me rewrite this. I have a negative 9 out here, a plus or minus, the square root. And what's 81 plus 40? That's 121. And it's divided by 4 because 2 times 2 is 4 on the bottom. Now 121 is a perfect square number. That's great because the answer will be 11, right? The square root of 121 is 11. So let's rewrite the whole thing now. Negative 9 plus or minus 11 divided by 4. And that plus or minus really does produce 2 answers. You have the negative 9 plus 11. You also have the negative 9 minus 11. Okay? And of course, it's both divided by 4. I'm sorry. So negative 9 plus 11 divided by 4 and negative 9 minus 11 divided by 4. Top one, bottom one. So let's do the top one. Negative 9 plus 11, that is 2. 2 divided by 4, you can't really divide 2 by 4, but you could reduce it. It becomes 1/2. The other one, negative 9 minus 11, that is negative 20. And of course, it's still divided by 4. And negative 20 divided by 4 is negative 5. So you get your two answers right there for this equation. If I were to graph this quadratic trinomial function, y equals 2x squared plus 9x minus 5, we would see that it opens up. It doesn't have the pattern 1, 1, 2, 4, 3, 9, but this parabola will be a little bit more narrow, and it will cross the x-axis at the value of 1/2 and also negative 5 on the x-axis. Let's move on to number 7. Okay, you cannot see your a, b, and c values unless it's in standard form. That's what standard form is, where you identify your ax squared plus bx plus c, but it has to be equal to 0. So we need to get that minus 12 over to the other side by adding it. And now we could actually rewrite the whole thing. 2x squared minus 9x plus 12 equals 0. And now you could say that your a value is 2, your b value is negative 9, and your c value is 12. So let's begin by doing our quadratic formula with parentheses. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Our b value is negative 9, put that right here and right there. Our a value is 2, put that on the bottom and up here. And our c value is 12, put that at the very end on the last parenthesis. Working on our discriminant, negative 9 squared, negative 9 times negative 9, that's 81. And then over here, 4 times 2 is 8, 8 times 12 is 96. And of course we have a minus sign if we didn't call it a negative 4. So that's negative 96 or minus 96. So we have 81 take away 96. That's going to be a negative number. I already know there's going to be no solution. But let's continue working here. The minus minus 9 becomes positive 9 plus or minus the square root of 81 take away 96. That's negative 15. And of course it is still over 4. But like I said, once you know that this discriminant value is negative, you know you're not going to have any real solution. It's going to be an imaginary value. You can't do the square root of a negative 15, right? So you know you're not going to get nice answers. I mean, you can't get real answers. They're imaginary answers. So again, because it's negative, you know it's going to be imaginary. You're not going to have real answers. Visually, that means that your parabola that opens up will not cross the x-axis. It's above the x-axis. So at this point, we could just say no solution. Could you guys do me a favor and check the back and make sure that that's the answer they give, no solution? Or maybe they say no real solution? Yeah, they have the no solution symbol, which is a 0 with a dash through it. Yeah, that means no solution. Okay, let's move on to number 9. Again, you can't do this until it's in standard form set equal to 0. So let's get rid of that 4. Subtract 4. We do to one side, do to the other. Rewrite the whole thing. 3x squared plus x minus 4 equals 0. Now you could identify your a value of 3, your b value of 1, and your c value of negative 4. And you could plug it all into negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Let's plug in our b value of 1 right there and right there, our a value of 3 down here and up here, and our c value of negative 4 on that very last parenthesis. Now let's work on the inside of the square root, which is called the discriminant value. 1 squared is 1. And then we say, so let me write that 1 right there. 1 squared is 1. And then the negative 4 times 3, that's negative 12. And negative 12 times negative 4 is back to positive, as in plus 48. So on the inside of our root, our discriminant value is really 49. So let me rewrite this whole thing. I have a negative 1 out in front, a plus minus the square root of, we said the discriminant was 49, and it's all divided by 6, because 2 times 3 is 6. Now the beauty of this one is that the square root of 49 is what? 7. So what we really have here is negative 1 plus or minus the nice beautiful number 7, no more square root, all over 6. Now the plus or minus produces 2 answers, right? You have the negative 1 plus 7 divided by 6, and you also have the negative 1 minus 7 divided by 6. Okay? So when we do the top one, negative 1 plus 7, that's going to be 6 over 6, which the answer is 1. And on the bottom, you have a negative 8 over 6, and reduce that, because you can't divide 8 by 6. Just reduce it by 2, and you'll get a negative 4 over 3. So both of those are your answers, 1 and negative 4/3. That second answer, negative 4/3, you could technically rewrite that as negative 1 1/3. If you turn it into a decimal, that would be negative 1.333333, right? Which is totally fine, right? You could turn it into a decimal, especially if you were graphing these answers, which are x-intercepts. These are the locations of where your parabola will cross the x-axis. It's going to cross at the value of 1 and at approximately negative 1.3. Let's go on to number 11. So again, you have to set it equal to 0 first. Subtract 15. Subtract 15. Rewrite it. You have 4x squared plus 7x minus 15 equals 0. Now you could identify your a value of 4, your b value of 7, and your c value of negative 15. And again, let's write our quadratic formula with parentheses. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So our b value is 7, our a value is 4, and our c value is negative 15. And now let's do the discriminant, right? The value inside of the root. 7 squared, that's what you always begin with. That's 49. Let me just jot that down right here on the side. And then this other value, you could call this a negative 4 times 4, that's negative 16. And then negative 16 times negative 15, it's going to be positive, but I don't know what that is. I want to do a calculator. I want to use a calculator right here. We said negative 16 times negative 15, and we get 240. Okay, so that's going to be a positive 240. Now, I do this math on the side, but that's what's going to be on the inside of the square root. So let me rewrite everything here. I have a negative 7 out in front, a plus minus the square root of 289, and it's all divided by 8. Now, I hope that 289 is a perfect square number, which I don't know. So let me try doing that on the calculator. The square root of 289 is 17. So luckily, 289 is a perfect square number. I didn't know that, but I checked it on the calculator and I saw that it works. The square root of 289 is 17. So this is what we have right now. We have a negative 7 plus or minus the nice beautiful number 17 divided by 8. So let's do the plus up here and the minus down here. So negative 7 plus 17 divided by 8. And also down here, the negative 7 minus 17 divided by 8. So up on top, negative 7 plus 17, that's 10. And 10 divided by 8 is a fraction 10 over 8. You could reduce it by 2, and it'll be a 5 over 4. And of course, you could change that to a decimal if you wanted to, or a mixed fraction, 1 1/4. Or you could say 1.25. But that's your answer, right? 1.25 or 1 1/4, whatever you want. I'm not really sure what they put on the back. But you also need the other answer, the minus situation. So negative 7 minus 17, that is a negative 24. And negative 24 over 8, that is divisible by 8, right? That gives you an actual negative 3 as a final answer. No decimal, no fraction, just a nice, beautiful negative 3. 24 divided by 8 is 3. A negative divided by a positive is a negative. So those are your two answers. Those are your two locations. If you were to graph the parabola, it would cross at negative 3 and at 1.25. Cross the x-axis, that is. So that's about all the odd ones for the first half. I'm going to make a separate video explaining the second half. Now, on the second half, I do want you to remember that you don't have to do the entire formula. You just have to focus in on your discriminant, right? And when you focus in on your discriminant, if it's positive, you're going to end up with two answers, two real answers. If the discriminant is negative, you're going to end up with no real answers because you can't do the square root of a negative number. And if your discriminant is 0, the square root of 0 is 0, and it doesn't matter if you add 0 or subtract 0, it's not going to make a difference. So when your discriminant is 0, you get only one real answer. So yeah, let's just save it for the next video.